Right, so guys, activity 43 then is 2012 higher level, okay? 2012 marks the century of the sinking of the Titanic, the world's most famous ocean liner, which was built in Belfast. The image on the right shows the new Titanic signature building, which was opened in the city to commence the anniversary in April. The building incorporates planar faces which intersect as shown to represent the bow of the ill-fated ship. Figure 3B3 below shows the planned elevation of a model of two such intersecting planes, ABCD and ABEF. The horizontal and vertical coordinates for the outer points of these two planes are also given. Okay, so if you look down here, we're given most of these planes. We have H in here for two of them, so we'll just worry about that in a second. So part A then wants to draw the given plan of the two intersecting planes and locate points A, B, D, and F in elevation. Part B then is determine the height for points C and E and complete the elevation. Part C is determine the dihedral angle between the two planes. Part D then is determine and indicate the horizontal and vertical traces of the oblique plane that contain the surface A, B, E, F. Okay, so we're going to look at that here, okay? So we're going to start by, again, roughly in the middle of our page. Okay. We're going to draw our axis line, okay? Now, they give us long measurements here, so I'm going to keep this out to the outside of my sheet, okay? And point A then is in 165. It's up 0 and it's down 70. That's point A. That's point A in elevation. Point B is in 205. Sorry, yeah, 205. It's up 80, down 110. Up 80. Down 110. Okay. So that's point B. Point C then is in 105. It's up a height we don't know. It's down 75. Point C. Point D is in 120. It's up 0. It's down 60. That's point D there on the edge. D there. Point D is in 170. It's up a height H we don't know, and it's down 10. That's point E. Point F is in 155. It's up a distance of 0. And it's down 25. That's point F. Point F. Okay. So we have two planes. The planes are A, B, C, D. So I'm going to start by joining up them. A, B, C, D, right, A. And A, B, E, F. Okay, so my elevation here, A goes to B. B goes to C, we don't have. C goes to D, we don't have. A back to B, that's fine. And then A to F. F to E, which we don't have. And E back to B, which we don't have. Okay, so that's our elevation plan set up. So part B then says, determine the height H for the points C, E, and complete the elevation. So we're looking for a height here, CE. Okay, so I need to see where this height is. How will I do that? Well, if I saw this as an edge view, I'd see the height, I could see the heights. So A and D are on the ground up here in the elevation, so that's a level line, AD. So if AD is level on the ground up here, I'm working with this plane only for a second now. If AD is level up there, that means that must be a true length. Okay, that's a true length. So what I can do now is, if I look out along that true length, set up 90 degrees to it. I'm going to project C and B out. I have a height for B, I don't have one for C. Project it out here. Okay? I'm going to take my heights in from elevation. So I know AD is on the ground. I have the height of B. Okay, and I can, that's an edge view. If that's an edge view, they should all intersect. So I can join A to D there, and that's going to be C there. C and E are both the same height, so that's my height there. So what I did was I got an edge view, got a true length, had my true length, went out, got an edge view. Once I had the edge view, then I was able to find the height of C. And now I can just project C up here, and the height for E up there. And that's my point E and my point C. That's point C. That's point E. Now I have them, I can finish off drawing my elevation. E comes down to F. And it goes up to B. I'll keep it light there. Okay, that's my elevation plan. Perfect. Determine the dihedral angle between the two planes. Well, they want me to get the dihedral angle between two planes. So, I need to get true length of my line intersection, which is AB. So, I'm going to set up perpendicular to AB. Perpendicular to my true length line. And project those points out there. What happens is C, D, E, and F are all in the same line as well. Okay. And I'm going to set up an X1, Y1. So now I need to take heights. Might reject these, fair enough. Okay, so D is on the ground up here. D and F are on the ground. D and F are on the ground. C and E are up. C and E are up this side. Point A is on the ground. You need to take the height of B then and stick it up there. Then the height of B there. Project it up here. That's B there. So I'm going to join A to B. A goes back to D, B goes back to C and E. And C and E go back to D and F. Okay, so that's now my true length of AB, which is my line of intersection. If I want to get, if I want to then find my dihedral angle, I need to look along my true length line. Set up 90 degrees to it. Project out all my points. That's my X2, Y2. Okay, and I'm going to take my distance from my X1, Y1 back to my previous distance, but I'm going to bring back a foreshortening line here now. And I'm going to stick it in E there. I'm going to label that just foreshorten. Okay, and I just take my compass and step off my distances, so that's E there. It's on the line. F. Take distance to A and B. Take distance back to C and D. Just starting to slightly roll off the page there. That's D there. And C is out there off the border. Okay, they should cross over now, so I join D and F, they cross. And I join that fella out on there. And that gives me a dihedral angle. Okay. Last thing then is determine and indicate the horizontal and vertical traces of the oblique plane that contains the surface A, B, E, F. A, B, E, F. Okay. What do we do here? We continue one of them on to get a point. So I'm going to continue AF along till it hits the ground. Continue AF along up here to hit the ground. That's going to be on the ground. So that means AF is already on the ground. So that means that has to be the horizontal trace. Okay. Now, if you did, you could continue on BE up along here to hit the ground, bring it up, extend BE till they hit, and then that'll give you 1 point in your vertical trace up here. You could do the same then for another point here, and that'll get it for you. But this is, BE is on the ground, so I just can use that as my HT. I want to find then my vertical trace. I'm going to go parallel to the horizontal trace through any point at all. I'm going to use E here. Bring it up, hits the ground, or it hits the ground. Bring it straight up. Bring it across, and where that intersects there, it joins back down to where my horizontal trace hits, and that's my BT hit. Okay, cool. Any questions on that? Give me a shout.